Red Block Math students. So I am starting a quick video about Lesson 4.1, Understanding Equivalent Equations. So the lesson objective, as you can see here, is whether or not you can identify equivalent equations. And of course, that's key vocabulary. So with Unit 4, we're getting into equations, which are different than expressions, because I'm going to pause and end up giving you an ed puzzle question on that. What's the difference between equations and expressions? Okay. And we're going to be looking at whether they're equivalent or not in this lesson. So if you want to follow along with your textbook, which I would recommend as we get into these more challenging lessons, it can't hurt for you to have your textbook handy. But what I'm going to be going over are the problems that are on page 194. Now on page 192 and 193, they give you lots of nice visuals about balance, scales, and how you balance things out. And of course, that's what I'm going to, I just got frozen there. That's what I'm going to explain to you as well. But if you want to look at the visuals, you can do that right now. I mean, not right now while I'm talking, but while you have your book at home. So this is on page 194, and this is example number A. And it says, state whether each pair of equations are equivalent equations, and then they're going to want to know why. So this is an equation right here, because we can see that it has an equal sign, right? The expressions that we had before did not actually equal anything. Now we've got an equal sign, which kind of makes sense that equations kind of have that root word in there, which would be equal. So they're going to have an equal sign, whereas expressions do not. So when you're doing equations, it's all about isolating for the variable. So isolating for the variable means getting the variable on its own on one side of the equal sign. And by doing that, we have to move the terms around to be able to isolate the variable. And that's what I'm going to talk to you about. How can we move terms around? Like, how does that work? So first thing that I see with this one, x plus 3 plus 6x equals 13. I see like terms, right? I have an x and I have a positive 6x. So because I have x plus 6x, those are like terms because they're from the x family, right? I can combine these. So x plus 6x is positive 7x, right? 1x plus 6x is positive 7x, but we know we don't need to write that positive sign. That's just like a given. So I have 7x plus 3, and that's what I have here. I'm going to check it off because I know I've written it down, equals 13. So I have 7x plus 3 equals 13. How can I make this 3 go away? Well, the only way I can make it go away, because I'm trying to isolate the x here, is to make this equal to 0. So how do I make positive 3 equal to 0? Well, I subtract 3, right? Because 3 minus 3 is 0. But if I'm going to subtract 3 on this side of the equal sign, I also have to do it on the other side of the equal sign. So that's where that balance picture was taking place on the other two pages. So if I do it on the left of the equal sign, I need to do it on the right. I need to do the same thing. So now I have 7x equals, now I don't have this anymore because 3 minus 3 is 0. So I've wiped that out. Equals, what's 13 minus 3? Well, it's 10. Now I have 7x equals 10. I'm going to move this right now. 7x equals 10. How do I get, and this is like saying 7 times x, right? How do I get rid of that coefficient? 7 times x, well, it's a multiplication. What is just like the inverse or the opposite operation of addition was subtraction? What's the opposite or the inverse operation of multiplication? Division. So if I divide 7 by 7, what am I going to get? 1, right? So if I divide this side by 7, I need to divide the right side by 7. So 7 divided by 7 is 1. 1 what? Well, 1x equals 10 sevenths. And in algebra, we don't write it as 1x. We would say x equals 10 sevenths. Now, it asked for equivalent expression. So the equivalent one that it gave me was 7x plus 3 equals 13. So this was the second, they said to compare these two and decide if they're equivalent expressions. So 7x plus 3. So see right away, all right, I'm kind of looking of what's similar. All right, well, this had a equals 13, so that was similar. This has a plus 3, and that's similar. And this has an x plus 6x, and this has a 7x. So I think they're going to be equal, but let's do this out. So I'm trying to isolate the variable. So I want to get rid of everything else that's with on the same side as the variable. So I'm going to say plus 3. Well, then to get rid of plus 3, I do the opposite, meaning I subtract 3. But if I subtract 3 to the left, I've got to do it to the right. Then I rewrite my step. 7x equals 13 minus 3 is 10. Now I've got multiplication here. What's the opposite or inverse of multiplication? Well, it's division. So I'm going to divide by 7. 7 divided by 7 is 1. So 1x equals 10 over 7. So these equations are equivalent because x is equal to 10 sevenths in both of those examples. Now I'm going to give you one on Edpuzzle to try on your own. Okay, so the second problem that they give us is to find out if these two equations, right, because they have equal signs, are equivalent or not. So I have 5x minus 4 equals 6, and I have 5x equals 20. Now you could be like, well, this one looks really straightforward because Mrs. Seward already taught us if there's a coefficient, right, we're trying to isolate x. So one thing is because there's only one term here, we don't want to move, we're not going to move x around, okay? We're going to leave x right where it is. We're not going to put it on the other side of the equal sign. So we're just going to stick with isolating it here to the left of the equal sign. So it's 5x. So the coefficient, it's 5 times x. So the inverse operation of multiplication is division, because if 5 divided by 5 is equal to 1, and then we've got 1x, so we have x all alone. But if I do 5 divided by 5 on this side, I need to divide by 5 on the right side. That's that scale, right, of balancing. If I do it on the left, I need to do it on the right. 5 divided by 5 is 1. 1x equals 20. These are both positive. So 20 divided by 5, positive divided by a positive is 4. So my final answer is that x equals 4. So now let's go over here. Anybody starting to think, mathematicians, if you can already figure out whether this is equal or not? 5x minus 4 equals 6. I love actually when there's a negative because it's it's really easy. What's the opposite of subtraction to cancel this out? This is negative 4. Well, then I'm going to have positive 4, right? Negative 4 plus 4, it's going to cancel it out and it's going to be equal to 0, right? So when I have a negative of a constant, all I need to do is add the opposite, right? Negative 4, the opposite is positive 4. But if I add 4 on this side, I need to add 4 on this side. Easy peasy, right? Now I'm going to rewrite it. 5x. I got rid of these, right? These canceled each other out. Negative 4 plus 4. And then I have equals, what 6 plus 4 equals 10. So you probably are noticing I'm writing every step out. And that's what I expect you to do. This is not the time to start doing everything in your head and be like, I know what it is, particularly because we're going to have positive negatives. Right now, they're giving you integers, but you're going to have fractions, you're going to have decimals. This is a time where writing everything out step by step and really being neat in your work is going to take you much farther and really make things much easier for you. This is not the time to be doing the math in your head, okay? So 5x equals 10. So again, coefficient of 5, I want to isolate it. It's multiplication, so I'm going to divide, because 5 divided by 5 is 1. But if I divide by 5 here, I need to divide by 5 on the right side of the equal sign. So 5 divided by 5 is 1x. 1x equal to positive 10 divided by positive 5 is 2. So drop my 1 now. X equals 2. So this equation, x is equal to 2. In this equation, x is equal to 4. So these two equations are not equivalent. All right, now you're going to try one on your own on the Ed puzzle. Okay, so this third example is a little bit different. They want to know if these are equivalent. So 2/3 x equals 4, and then they've given us a value for x equals 6. So we actually don't need to do any work here, okay? So 2/3 x equals 4. So because they've given us a value for x, I'm going to say, let's go ahead and substitute and see what we come up with when we put in the value of 6 for x. So I am going to, when I say substitute, that's when we plug in the value, right, that we've been given for x. So here is 6. So over here, I'm going to write 2/3, and x is, we're plugging in, we're substituting the value of 6. And I just wrote it as 6/1 because I know I'm doing multiplication here. And I just want to make sure that my numerator and denominator are kind of lined up. And then equals 4, because that's what we've been provided with. So I have 2/3 times 6. So of course we can use our good old cross simplifying. So 3 goes into 3 once, and 3 goes into 6 twice, right? You saw what I did there? 2 times 2 is 4. 1 times 1 is 1. And then I can rewrite that as just simply 4 equals 4 and get rid of that denominator. So when I substituted the value of 6 into this equation, and I did all of the steps out, I got 4 on that side of the equation, right? 2/3 times 6, or 2/3 of 6 is 4, and 4 equals the 4 that it had provided me with. So in this case, they are equivalent equations. So the misconception here would be like, wait, Mrs. Seymour, but x equals 6. And now we have 4. Like, how can that be? Well, because what we did is substitute here. We substituted the value of x equals 6, and we substituted it into an equation here that was saying like 2/3 of 6. So 2/3 times 6 equals 4. And when we substituted that value into that equation, we did get the answers that were equivalent to each other. So therefore, these equations are equivalent. So when you have a problem that asks you to determine if it's an equivalent equation, and they just give you a value for the variable, just go ahead and plug that value into that variable and do the work out. And as long as you get that the numbers at the bottom are equal, then you have equivalent equations. So I'm going to have you try some on your own now.